Alrighty, guys, let's take a look at our first problem where we have Mr. Denny pulling a sled full of adorable puppies across snow so that they accelerate at a rate of 0.29 meters per second squared. Mr. Denny's force is up and at an angle of 22 degrees. The puppies and the sled together have a mass of 26 kilograms, and the force of friction on the sled is 188 newtons. All right, so let's start working through this and hopefully we can find out all of the answers. First one says, what is the net force in the x direction? So before we do any of that, we need to draw a free body diagram. So I'm just going to add it right here on top of my picture. I know that this is flat on the ground. I can see that. So I'm going to have force gravity pointed downward. And then after force gravity, I'm going to have force normal pointed up because it's flat on the ground. I can see that this rope is up at an angle, so that's going to be my force applied. And then it also says that there's force friction, so I'm going to draw force friction pointed in the opposite direction. This is just a rough outline of my free body diagram. It's not perfect, and the reason is that the size of the arrows, but that's okay for now because we're just using it to help us solve this problem. After we've drawn force applied, we can go ahead and split force applied up into the x and the y. So this is my x component, and then my y component is going to be this one right here because it is pointed up from the ground and it's in the same plane as normal and gravity, and that's where my y component should be. All right, so now we can go ahead and solve for the net force in the x direction. We know that net force in the x is going to be equal to the forces that point in the positive direction, which we're going to say the positive is to the right. So this is positive x, and the positive y is up. So the forces that point to the right, well, we can see that that's force applied in the x direction, so FAX, minus the forces that point in the opposite direction, and that would be force friction. An easy way to tell what's in the x and what's in the y is just to circle or square off what is the x direction and what is the y. So right here we see this is the x. It is parallel to the ground. We know that this is equal to mass times acceleration. So in order to solve for net force, we're going to need some variables here. We need FAX and we need force friction. We have force friction, but we technically don't have FAX. We do, but it's kind of hidden. So we're going to say that we don't know what FAX is, and we also don't know what net force in the x is. But we do know what the mass is, and we do know what acceleration is. Therefore, we can go ahead and use this part of the equation and this part of the equation to solve for net force. So I have net force in the x direction is equal to mass times acceleration. We have all these variables. Right here, we know that the mass is 26, and we know that the acceleration is 0.29 meters per second squared. Therefore, the net force in the x direction is equal to 26 times 0.29. If we do the math, we find out that the net force should be equal to 7.53 newtons. Go ahead and write that right here, 7.53 newtons. Now that we have the net force, we can go back and solve for the force applied in the x direction. So we have net force now. We know force friction. We're going to go ahead and use this part of the equation now to solve. And if we do that, we see that net force in the x is equal to FAX minus FF. So to get FAX by itself, we're going to add FF to the other side. So we get net force in the x plus FF is equal to FAX. Now we just need to plug in our numbers. Net force in the x is 7.53. FF, I'm going to have to scroll up to look at that. FF is 188 newtons because it tells us in the problem right there. So I'll do plus 188 is equal to FAX. Therefore, after we do some simple algebra, we get that FAX is equal to 195.53 newtons. Going to take that and go ahead and write it up here, 195.53 newtons. Okay, now that we have all this info, we can go ahead and start solving for FAY. So FAY, there's two ways to solve for it. The first one is to take our net force in the y direction and take the forces that point up. So looking at my diagram, I see that force normal is in the y direction, force gravity is in the y direction, and also FAY over here is in the y direction. So the forces that point up would be force normal, and we also have FAY, so plus FAY, and then force gravity points down, so minus FG. We know that this is balanced in the y direction because the sled is not moving up and down or accelerating up and down, it's just moving along a parallel path to the floor, only in the x direction. Therefore, the net force is just equal to 0 newtons in the y direction. In order to solve for FAY, then, we're going to need these other variables. We can solve for FG, but we don't have an equation for Fn right now. So that means we also still don't know FAY. So in order to solve for FAY, we're going to have to take a different approach. If we use our triangle from our free body diagram, we can see that the horizontal, or the FAX, is right here on our triangle, and we have our angle as well, and then FAY is over here. So I know what FAX is because I just solved for it. FAX is 195.53, and the angle, which was given to me in the problem, is 22 degrees. So this angle right here is 22. So in order to solve for FAY, I need to use trig. Which trig function? Well, this is the opposite, and this is the adjacent right here. So if I have opposite and adjacent, I'm going to use tangent. Therefore, I have tangent of my angle, which is 22 degrees, is equal to the opposite, which is FAY, over the adjacent, which is FAX. FAX we know to be 195.53. So in order to solve for this, I'm going to have to go and multiply my 195.53 to the other side so that I get FAY by itself. I find out that FAY is equal to 195.53 times tangent of 22. Plug that into your calculator, and we get FAY is equal to 79 newtons. Go ahead and add that up here as well. Now it wants us to figure out what is the total force Denny is applying on the sled of puppies. So that's really just talking about our force applied. So the force applied would be our hypotenuse of this triangle. We know what the x is, we know what the y is, so we could just do a squared plus b squared equals c squared, or we could use another trig function. I'm going to go ahead and just use another trig function because I love them so much. And let's use our FAX value because we solved for that before. And we're going to also use FAX just in case we made an error solving for FAY. So to figure this out, I have adjacent and I'm solving for the hypotenuse. So adjacent and hypotenuse means that I'm going to use cosine. So I have cosine of my angle, which is 22, is equal to the adjacent, which is 195.53, divided by the hypotenuse, which is FA, and that is also unknown. So to get FA by itself, I'm going to cross multiply. I end up with FA is equal to 195.53 divided by cosine of 22. After we plug this into our calculator, we find out that the force applied should be 210.89 newtons. Let's take this answer, plug it in up here, 210.89 newtons. Last part that we need to solve for, and I kind of cut it off a little, is what is the normal force? And we have that equation right here. So if we take this equation, now we know what FAY is, so this question mark is no longer there, and it's now a checkpoint because we have this value. So we can just go ahead and use this part of our equation to solve. So if I do that, I'm going to scroll down a little and write it down. I get Fn plus FAY minus FG is equal to 0. Therefore, to get Fn by itself, I can just go ahead and add force gravity and subtract force applied y over. So I find out that Fn should be equal to Fg minus FAY. I have values for these, so I'm going to go ahead and start plugging them in. So Fn is equal to Fg. Fg is just the mass times gravity, and the mass in this case is 26 kilograms. So 26 times 9.8 minus 79. So go ahead and solve for that, and we find out that the force normal should be 175.8 newtons. Question that we need to consider is, why is force normal equal to force gravity minus FAY? Well, if we look up here, we're pulling upward, and if we're pulling upward, our force normal does not need to support as much weight as usual. And remember, force normal is the force that the surface is feeling, and we're taking some of that force or some of that weight off of the surface by pulling upward. So it's always important to think about the direction that we're pulling in and how that surface is going to feel that force based off of whether we're pulling up or if we're pushing down.